Hello, this is Module 4, Lesson 4, Solving a Linear Equation. You should be on page 22 of your student notebook, and your essential question for this lesson is how do you solve a linear equation? First of all, what does it mean to solve a linear equation? Hopefully you remember from yesterday's lesson, when we're solving a linear equation, what we're doing is we are finding a value for the variable that makes both sides of the equation equal in value. The left side of the equation would be equal to the right side of the equation. We're going to go through several examples, and this should become really clear by the end of today's lesson. In some cases, we have really simple equations, and simple guesswork will lead us to the solution, or if you know your multiplication facts, you right off the bat are going to be thinking, I know the answer to this question. So looking at the equation, 4x plus 1 equals 13, what number for x would make this equation true? And some of you right now are going, oh, I know that's going to be 3. And others are going, how would she know it's 3? Is she just pulling that number out of the air? No, I'm thinking about my multiplication facts. And 4 times 3 is 12, and 12 plus 1 would be 13. So I know that if I substitute in for a 3 for x, it's going to make the equation true. Let's go ahead and do that. I'm going to show you how I would expect you to show your work on something like this. And yes, I know, even though it's a simple equation, I would expect you to still show your work. So 4 times 3 plus 1, is that equal to 13? 4 times 3 is 12 plus 1, and 13 would equal 13. And yes, both sides of the equation then are true. So for some simple problems, guess and check is going to work. Or if you know your multiplication facts, you're going to have a better idea of the number that would be substituted in to make the equation true. What about when we have a complex equation? What if we're looking at something like 3 times the quantity 4x minus 9 plus 10, is that equal to 15x plus 2 plus 7x? Could we guess a number for x that would make this equation true? I don't know about you, but I don't think I can. I can't guess and check with how much work that would be. Now we could try simplifying the equation a little bit and see if we can make it maybe a little bit easier to decipher and understand the equation and see if maybe if we distribute this 3, let's see, 3 times 4 is 12x. 3 times negative 9 is going to be negative 27. Plus 10, is that equal to 15x plus 2 plus 7x? Yeah, it's still not working for me. It hasn't gotten simple enough. Well, maybe we could even simplify. We can combine some like terms. We've got negative 27, negative 10. Neither one of those have a variable, so I can combine those. So I've got 12x minus 17 equals, let's see, on the other side we've got a 15x and we have a 7x, so those can be combined. So we'd have 22x plus 2. Yeah, well, I'm looking at it and I still cannot think of a number that would work to make both sides of the equation true. So I would have to use some different problem solving techniques. Guess and check is not going to work here. So we're going to look at different strategies, different problem-solving techniques that are going to be more efficient than guess and check, especially when we have more complex problems. So let's go ahead and turn the page and get to it. So we have a simple equation. 4x plus 1, is that equal to 7 minus 2? I'm sorry, not 4x, just 4 plus 1. Is that equal to 7 minus 2? Let's see, 4 plus 1 is 5. Is that equal to 7 minus 2 is 5? Yes, it's equal. So both sides, the left side of the equation and the right side of the equation, are equivalent. Okay? So now we're going to go through a series of directions. It says perform each of the following operations and state whether or not the equation is still true. So you have a direction here on the left side. The first one says add 3 to both sides of the equal sign. So 4 plus 1, I'm going to just do a plus 3 out in front, and then 7 minus 2 plus 3. So let's see, 3 plus 4 is 7 plus 1 is 8. 7 minus 2 is 5, plus 3 is also 8. So yes, they're still equivalent. They're still equivalent. What I'd like you to do right now is pause the video and go ahead and do the operations on the rest of this page and the top of the next page. So whatever it's telling you to do on the left side, that's what I want you to do on the right side. And I did recopy that original equation on my copy, and I know that's not done in your student book, so you're probably going to want to do that. Take that equation from up top and just write it in, and then perform whatever operation it's telling you to do. So go ahead and pause the video right now, do those problems. It should take you all of maybe 30 seconds, and then unpause the video. Okay, well, I'm hoping that you did indeed take the time to pause the video and actually do the operations that they were asking you to do. They were very simple. So if we did that one together. So the next one, if I add 3 to one side and 2 to the other side, I get 8 on the left side of the equation and 7 on the right side of the equation. And no, they are no longer equivalent. If I don't add the same number to both sides, I'm not going to get the two sides of the equation still being the same. The next one says subtract 6 from both sides of the equal sign. So if I subtract 6 from the left side, I get -1. Subtract 6 from the right side, I also get -1. So yes, that keeps them equal. The next one, if I'm subtracting 3 from both sides of the equal sign, so the left side, I get 2. The right side, I also get 2. Yes, that's going to work. If I multiply both sides by 10, I get 50 equals 50. Again, yes, that maintains their equality. And the next one, if I multiply the left side by 10, but I only multiply the right side by 4, no, they're no longer going to be equal. And the next few problems, if I divide the left side by 2, I get 5 halves. I mean, you might have, if you used your calculator, you might have gotten, what, 2.5 here. Same thing on the right side, 5 halves. So yes, that maintains their equality. But if I divide one side by 2 and the other side by 5, all of a sudden they're not equal anymore. So what do we notice? Hopefully you notice that if you're doing the same thing to the left and the right side of the equation, you're going to keep the equation being equal. This is called the properties of equality. There are 4 of them. All 4 properties of equality, I don't know why I'm getting that weird box, all 4 properties require that we start with the left side of the equal sign and the right side of the equal sign being equivalent. So if the equation was not equivalent or not true to begin with, we couldn't have added or subtracted those numbers to either side of the equal sign and maintained their equality. So the first point, or the first property we want to talk about, is the addition property. If you add the same number to both sides of the equation will still be equal. Similarly, the subtraction property of equality, if you subtract the same number from both sides of the equation will be equal. I know, multiplication property of equality, if you multiply both sides of an equation by the same number, the equation will be equal. And you guessed it, division is the last one. So if you divide both sides of an equation by the same number, the equation will still be equal. You can put this in your own words. You can cut down my words. You can pause the video and write down everything. However you want to handle the notes here. You should note, however, that there are 4 different properties of equality: addition, subtraction, multiplication, and division. Basically, what they're saying is whatever you do to one side of the equation, you must do the same thing to the other side of the equation if you want the equation to stay equal, which is what we want to do when we are solving for them. If you look at page 26 is out of order. We actually have to flip really quickly to page 27 and take a look at the problems that are, I'm sorry, oh, they're even numbered badly. So the next, after 24, it says 26. We want to flip to 25, which is on the next page. You should see example 1, and it says solve the linear equation 2x minus 3 equals 4x. So what I'm going to do is I'm going to rewrite the equation just as it is on the right side, because when we're using Cornell Notes, one of the ideas of Cornell Notes is we keep all of our writing on the right side so that when we're studying for a test, we can cover up the right side and try to solve it again. So I've got 2x minus 3 equals 4x. So the first thing that I want to do, because I've got variables on both sides of my equal sign, if I'm going to try to solve this equation, I need to move all of my variable terms to one side or the other. And I always want you to start with trying to get all the variable terms on one side or the other. Now, I am partial to positive numbers. Positive numbers are easier for my brain to comprehend. And so I'm going to move my 2x over to the other side. And the way I'm going to do that is by using the subtraction property of equality. And I'm going to subtract 2x from both sides of the equal sign. So positive 2x minus 2x ends up being 0. I still have something on that side of the equal sign, though. I've got a negative 3, so I'm going to bring that down. 4x minus 2x is going to be 2x. And that is the subtraction property of equality. The next thing I need to do is get x all by itself. So now I'm going to divide both sides of the equal sign by 2, because I want to undo this x, or this 2 times x. I want to undo that, so I'm going to use division. So divide by 2, and I end up with x equals negative 3/2. If you were using your calculator, you might have gotten negative 1.5. That's fine. It means the same thing, but I'd like for you to leave it in an improper fraction. And when we're graphing, you're going to see why. Fractions are just a lot easier to deal with than mixed numbers when you're trying to graph an equation, and that's coming. The cool thing about algebra is we can always check our work. So to do the check here, just like yesterday's lesson, we're going to take our negative 2/3 and plug it back into the original question, or the original problem. So 2 times negative 3/2 minus 3, is that equal to 4 times negative 3/2? Now, those of you that aren't terribly good at multiplying fractions, especially multiplying fractions in your head, you might want to grab your calculator at this point. I'm going to go ahead and do this in my head. I know 2 times negative 3/2 is going to be a negative 3. So negative 3 minus 3, does that equal, let's see, 4 times negative 3 is 12, divided by 2 is negative 6. Negative 3 minus 3 is also negative 6. Negative 6 equals negative 6, so I know my answer is good. If I plugged in or I substituted in my answer for the variable and it didn't work, then I would know that I did something wrong. What I'd like you to do right now is go ahead and pause the video and try doing the on your own problem number 1. Oh, you know what? I'm sorry. Let me take that back. Let's work another problem together, and then I'll have you do that. So example number 2. Same thing. We're going to try to solve this equation. Let's take a look at it. We've got 3/5 x minus 21. Does that equal 15? So I want to find out what values of x will make this true. So all of my x terms are on one side of the equal sign. I don't have to worry about moving that around anywhere, but it has other things with it, and I want to try to get that variable alone. I want to isolate my variable. So what I want to do first is get rid of this minus 21. So how do I undo a minus 21? I'm going to add 21 to both sides of the equation. So on the left side, I'm going to have 3/5 x equals negative 21 plus 21 would be 0. I don't have to write plus 0. 15 plus 21 is 36. And next I have 3/5 times x equals 36. So you might be thinking, I need to divide by 3/5. Hopefully you remember back to when you were learning about fractions that when you're dividing by a fraction, what you're actually doing is multiplying by the reciprocal. So I'm going to multiply the left side of the equation by 5/3. That means I have to multiply the right side of the equation by 5/3. So when I do that, I end up with x on the left side equals 36 times 5/3. How I would do this, if you're, you could use your calculator, or if you're doing it in your head, you'd take 36 times 5 and then divide by 3, or you could simplify first, divide 36 by 3 and then multiply by 5. So 36 divided by 3 is 12, times 5 is 60. So my answer here is 60. If you want to check me with a calculator, go ahead and do that. So I can, let's see, I've used my addition property of equality and I used the multiplication property of equality. What that means is whatever I did to one side of the equation, I had to do to the other side of the equation. Same thing here. I multiplied by 5/3. I've got to multiply by 5/3. Get x equals 60. Let me check my work, make sure that it's right. Those of you that are saying, do I have to check my work? Yes. Why would you not want to? Why would you not want to make why would you not want to make sure that you have the right answer? Minus 21 equals 15. So 5/3 times 60 is going to be 36. Minus 21 equals 15. And 15 does equal 15. So we got it. Okay. We're going to go back to, well, we're going to go to page 26, which again, it was just flipped and it's not in the correct order. We want to talk about two other properties that make problem solving or solving an equation more efficient. Hopefully you all remember the distributive property. We've talked about it a little bit. Look for parentheses. If the equation has parentheses, you need to distribute whatever's on the outside of the parentheses to all the terms on the inside of the parentheses. And then you can continue with the problem. The other properties, Eureka teaches it as the commutative and associative properties of addition, which means we can rearrange and group like terms to combine them and simplify the problem. The way you might have learned this in 6th and 7th grade is by circling or putting a box around terms that have the same variable, and those are the ones that you know that you can combine. So let's go ahead and do a couple more problems together. This next one down below, 1/5 x, I'm going to rewrite it over here on the right, 1/5 x plus 13 plus x, does that equal 1 minus 9 x plus 22? Okay, we're dealing with fractions. Fractions, again, nothing to worry about with fractions. They are your friends, but just some people get a little bit nervous about them because they didn't get a real solid background with them. When we don't have any number in front of our variable, what is there is a 1. Okay? When we are trying to add fractions, we have to have the same denominator. We can't add fractions that don't have the same denominator. So if I want to combine, if I'm saying I've got an x term here and an x term here, they're both on the left side of the equal sign, so I want to combine those, what I have to do is I have to turn this 1 into a fraction. And the way I do that is 5 divided by 5x, because 5 divided by 5 is 1. So now I've got 1/5 x and 5 divided by 5x. I can add those together. I'm combining these like terms. So I will have 6/5 x plus 13 equals, let's look at the right side. What kind of like terms do I have on the right side? I've got a 1, positive 1, and a positive 22. So I can combine those. I don't have to convert anything. 1 plus 22 is 23. So I know I'm going to have 23 minus 9x. Okay. The next thing I want to do is get all of my x terms to one side or the other. Again, I'm partial to positive numbers, so I'm going to move my negative 9. So I'm going to add 9x to both sides. Uh-oh, again, I've got to deal with this fraction issue. Again, I have to have the same denominator. So I know that 9 is the same as 9 over 1. And if I want to have a denominator of 5, I can think about what I can either cross multiply here. 9 times 5 divided by 1 is going to be 45. Or I can think about 1 times 5 equals 5, 9 times 5 equals 45. Either way. So I know I can replace this 9, instead of having a 9 there, I can say that it is 45/5 x, and I'm adding that. So I add just my numerators. So 6 plus 45 is 51, 51x, or I'm sorry, 51/5 x plus 13 equals 23. And the last thing I have to do is the subtraction property of equality, minus 13, minus 13. So I have 51/5 x equals 10. Now to undo this multiplication, I'm going to multiply by the reciprocal. So I'm going to get x equals 51s. And yes, I did give you that challenge to go ahead and check your work. This is going to be an ugly check. So 1/5 times 50 51st plus 13 plus 50 51st. Does that equal 1 minus 9 times 50 51st plus 22? And I'm out of space. I'm going to plug this into my calculator, and I'm going to ask you to trust me. It is 14.17647 and continues, and that is indeed equal to 14.17647 and continues. So it is a good answer, but it's an ugly check. What I'd like to do right now, I know we're going a little bit long here. I apologize. Let's do, you know what, we'll save it for tomorrow. We'll save it for tomorrow. If you want to try to tackle some of the on your own problems, go ahead and do that. Otherwise, I will see you in class tomorrow. And for our warm-up, we will do the on your owns and have some interactive activities. Have a great night, and I'll see you tomorrow. Bye-bye.